Hi everyone, there's a nice problem today from sequences. Okay, the question is that a sub n is sequence, given sequence. So in the sequence a sub 0 is 0, a sub 1 is 1, and there is a relation here, a sub n equal a sub n minus 1 plus a sub n minus 2, and 0, 1, 1, 2, 0, 2, and so on. These are the remainders divided by square. Actually, these are the values of the given, the values of the terms of the given sequence. So that are obtained by, as remainders divided by square. Okay. So the question is to find a sub 2017 plus a sub 2018 plus a sub 2019, a sub 2020, 2021, 2022, up to 2024. That's fine. Actually, this question looks quite challenging. It's a little bit challenging, but what we have to do here is to understand the sequence and the remainders. So actually, it's the main point. If we are able to, just differentiate and group the remainders, we will just reach the half of the let's say our road. Okay, let's write the solution and begin. Solution. Okay, so now let's check some values here. Okay, so we have a0, a1, why not a2, a3, some values. For example, up to a10, a to 10, because in that case we can and we can create the patterns. Okay, and when n2, let's check n2. It will be a sub 2 equal a sub 1 plus a sub 0. It will be 0 plus 1. It will be 1. Okay, we can write mods free, but I've already written divided by 3. So okay, a2 is 1. So now let's check n's frame. It will be a3 equal a2 plus a1. So a2 is 1. As you see, a1 is 1. So 1 plus 1, 2. Okay. So a2 a3. Now let's check n4. So a to 4 will be a3 plus a2 according to the general formula. A sub 2. Okay. A3 is 2. Let's write 2. A sub 2 is 1. So 1 1's 3. But as we get 0 when divide 3 by 3, so we can write, because it is actually we can write mods 3 because they are written here divided by 3. So it will be just 0. We just take the remainder. So a4 is 0. Now let's check 5 and 5. And 5 just a to 5, a sub 5, a sub 4 plus a sub 3. So the 4 was 0. Because these values of the terms of the sequence are the remainders divided by 3. That means we will decide the values, then we just get the results like mod by 3. But most free, like most free. So that's why it's free means 0. Most free. So a3 is 2. Okay, it's just 2 because 2 most free, no need to write because it's a remainder. Okay, let's check 6 and 6. A sub 6 is sub 5 plus sub 4. Here, let me make it better for you. Okay. It will be just 4. A5. 2 plus 4 is 0, it is just 2. Okay, you may not think that you sometimes get the same values. Okay, we do that. Let me just write the values here in order to continue. So 2. We can also, guys, create a, we have to see the pattern here. So in order to see the pattern, we shouldn't look at the whole picture. We have to separate them. So if we just look at 0, 1, okay, for example here, a sub 2, 1, 2, 0, 2, 2, okay, so if we just compare this, we will see the first 6 terms here, 6 values, 0, 0, 1, 1, a sub 2 is 1, then 2, 0, 2, okay, then next 2 here again, okay, so let's try here a sub 7. Let me just write a sub 7 and find up to 10. It will be 6 plus 5. I don't write anymore. 6 plus 5. 6 is 2. 5 plus 2. 2 plus 2, it is 4. But we know that the modes 3 will be just 1, remainder 1. So just we can write 1. We can write 1. So A sub 8 will be 7 plus 6, according to general formula. So 7 is 1, 6 is 2. 1 plus 2, it was 3. So 3 means 0, because it is, without any remainders divided by 3. 8 to 5, 8 to 5, it is 8 plus 7, it's 1, because 0 plus 1, and 10 will be 9 plus 8, it will be 1. Okay, fine, we found some values here, from 0 to 10, but we had 0 and 1 beforehand, first 0th and first terms beforehand, so we actually calculated the values of other terms up to 10. That's great. So if we look at the patterns here, we will not see anything, because so just 0, 1, here 1, 2, 0, 2, 2, 1, 0, 1. Okay. But if we separate them and group as even and odd index terms, I think we will see great thing there, great picture. Okay, let's group them. So let's group them where? Okay, let's erase this part. Now let's just look at them in different groups. So let's write even group. By even group, I mean terms of the sequence with the even indexes. Okay. So A0 was, of course, 0 is also even. So it is 0. Okay, A0. 0, A2, A sub 2, it was 1, okay, A sub 4, it was 0, okay, fine, and A sub 6, it was 2 here, 2, so A sub 8, let me check sub 8, A8, it is again 0 here, 0, okay, and A sub 10 here is 1. So actually, if you check, you will see that A sub 12 is 0 and A sub 14 is 2. So, just remainders like 0, 1, 0, 2, or, in other words, the values of the even index terms of the sequence are just repeated, like periodically 0, 1, 0, 2. That's perfect. So actually, if you knew how, what kind of patterns the even index number terms of the sequence just follow. Okay, so here's our pattern here for even number terms 0, 1, 0, 2. So because every 4 terms for even index terms, they will be repeated. Now let's do the same thing for odd number terms. Okay. So let's now, okay, here, so let me erase because we already knew the point. So let me write it here, 0, 1, 0, 1. So, and we don't need this part. We already know what we need. Okay, so I'm writing here already even. By even, I mean even index terms here. They just are like, 0, 1, 0, 1, 0, 2. This is how they, just how they vary. 0, 1, 0, 2. They just go like this. Okay, now odd numbers. Let me just write, make a part for odd. So they may change every 4 terms. For if you don't know it. So if you look at it, of course, it will the first will be A1 because it is odd number. Odd index, odd number term, let's say. Okay, so it's A1 is 1, fine. A3 2, okay, A3 2, A5 2, A7 here 1, A9 we have found it 1. I mean, so actually you can check if you want to be sure. You will see that odd index number of the odd index number terms of the sequence we'll just only get values like 1, 2, 2, 1, 1, 2, 2, 1. So they will periodically change like 1, 2, 2, 1. They will not give nothing different from the values. So even for even numbers, the pattern here 0, 1, 0, 1 patterns. For odd, so we know that we have what is wanted here is to find the given sum. Of course, this sum includes some odd and some index, odd and even index numbers. Okay, but we have to be here careful because we will not try to find the values in the given sequence, because we will separate the sequence to different like sub sequences, one even number sequence and odd number sequences. So first we have to create new sequence here. So okay, let's erase here because we already know what happens here. Okay. So fine. And now let's first find how many, because the last year term is 2024. So now let's find how many terms in even index sequence and how many terms are there in the odd index number terms. Okay, first let's do it for even number. So first is A0, last 2024. Let's find 2024 minus 0 over 2. I'm going to find here the number of the terms in even numbers. Plus 1, it will be 2020. It will be just 2024 over 2. It is 1012. It's 2013 terms. It is for A 2024 will be B 2013 because it's last term. So that means A 2022 will be like this. A 2020 will be B 2010, like 1010. So here they just change it by 2, here 1, because this is new set. This set B is a set of only even index terms, but A is the whole set, whole sequence. So A 28, because that's the thing I will, as a final value I have to find, because A to 18 and A sub 27. So it will be just 1009. Okay, fine, that's great. And now let's find what we need. So here as terms here change, like if you look at even number terms, we see that patterns like 0, 1, 0, 2. Okay. First we have to find it. B sub 1013 or 1013. Okay. So they change every 4 numbers. They just repeat every 4 numbers. So if we divide the given index by 4, 1013, we will get 1 remainder. 1 remainder means we will get back to the head or top beginning. It is 0. That means this value is 0. This value is 0. B13, B sub 1013 0. It means A sub 2020 was 0. That's great. So A 2022, it is B 1012. Okay. 12, when we divide by 4, 12 is divided by 4. It's perfect division. Okay. So that means completion. We take 2. Okay, it means 4, 2. So this number term is 2. 2020 is B1010. Sorry, no. It is B1011. Sorry. 11 here, 10. Okay. 13, 12, okay, 10. There. When we divide by 4, it is free remainder. 3 means third. We will take third, it is 0. And when we divide by this guy, it is just remainder is 2. 2 means we will take second, it is 1. Okay, fine. We need the values of A sub 2024. It was 0, A 2022, 2, A 2020 0, and A 2018 1. These are repeated patterns, perfect patterns. Okay, we're going to finish the problem, but we still have to find the values. We have to use the same strategy to find to do the same thing for odd number terms. Okay, odd index number terms. So let me write here now. Okay, let me erase this part. So similarly, we can find guys. Here, let me write odd. So last term here from odd is 2023. So let's find here. We're going to find the number of the terms. 2028 minus first is A1, 1 over 2 plus 1, the number of the terms. It is 22. So this total number will be, I think, this number, because 22 over 2, it is 10, 11, yes, exactly. Okay, so these values are like these values, because, no, they are different, 1, 0, okay, 1, 0, anyway. But this sum is free. This sum is free. So, the sum of the even indexes, their sum. This is free. Okay, we knew their sum is free. Okay, let's write free here. So we can already erase this part because we need space to do the same thing for odd index number terms. So it's free, the sum of the even index number terms. Okay. So first let's begin with A2023 from the end, because the last number is 10, 12, so it will be B or C, for example, C. It will be C, this, okay? So this guy is divided by 4, because here again, patterns are like 4. Every 4 times they are repeated. So 10, 12, when we divide by 4, it is, 0, there is no remainder, 0, because 12 divided by 4, okay? So 0 means the last one, 1. It is 1. Okay, that means 8, 20, 23 is 1. 8, 20, 21. C. So it will be C. 10, 11. Yeah. Okay. It will be, when divided by 4, the remainder is 3. 3 means we will take here 2. 2. So A 2019, it is C 1010. So remainder is 2. Remainder 2 means the second, it is 2. And A 2017 is C 109. It is remainder 1 means 1. Okay. So we found the values of the terms that are wanted from us. So their sum is 1, 2, 4, 6. So 6 here, 3 we had found beforehand. 6, 3, 9. The result is 9. Let me write the result. Let me write the 9. 9 is the result because you get the sum of the given values. 3 we had found. So here 6, 9. So that is the answer. The answer is 9. I'm really happy that I just, showed the solution of this brilliant question to you, because these kind of questions are kind of trampoline to first, second, or third step Olympiad problems, and also, just kind of warm up to believe yourself that you can do for other more challenging Olympiad or math problems. Okay, that's the answer 9. So we just end up here. See you guys.